All right, we're going to do a recording here for the second part of Chapter 4. I'm on page 343, and we're looking at 4.5 on sketch and sine and cosine. So in general, oops, I got to get my pen here. In general, thinking about your unit circle now, about these points, 1, 0, 0, 1, negative 1, 0, 0, negative 1. And we're looking at a normal cycle from 0 to 2 pi. Highest it can go is 1 and negative 1. So the sine of 0 right here is 0. The sine of pi over 2 is 1. The sine of pi. So there's my sine curve. Now if I do another cycle of it, again, this negative pi over 2 is the same. Negative pi, negative 3 pi over 2 is the same as positive pi over 2. So there's two cycles of the sine curve. Okay, so if they did 2 sine x, then the amplitude changes, so then this dot goes up there, and so now your cycle would be like that. Okay? If it's negative, then you have to go opposite. So it would look like that. So I think if you just get these things, if the number out front changes, then the amplitude and the range change. All right, cosine. Again, let's do from 0 to 2 pi on both sides. Okay, the cosine of 0 is 1. The cosine of pi over 2 is 0. Cosine of pi is negative 1. 3 pi over 2. So there's one cycle of the cosine curve. So again, if I do it from over here, you got the same thing. So that's what cosine looks like. So sine looks like this. Cosine looks like that. One cycle. All right, what if you have y equals 3 cosine x? Well, then instead of going at here, I got to start there, and at the min it's going to be there. So this thing would go like that for one cycle. Okay? So in your homework assignments or on the review, it says sine 6x. Now, the period is always 2 pi divided by the coefficient in front of the x. So my period here is only pi over 3. So when I do my scale now for one cycle, I put pi over 3 like right there. Well, halfway then is going to be pi over 6, and halfway there and halfway there. So we got to think about this now. Half of pi over 6 is pi over 12. So this would be 1/12, 2/12. This would be 3/12, and 3/12 is pi over 4. So this thing starts here, halfway, all the way, 1/4 of the way. So there's your, now notice my labeling. Okay, so then if this was 2 pi, and then we have to go halfway between 1/3 and 2/3, right? So if we put 2/6 and 4/6, this is 3/6, so that's pi over 2. And that would be like 5 pi over 12, 7 pi over 12. And then this thing goes like this for a second cycle. So again, if the period is pi over 3, just change your x scale so that if you had to do 2 cycles, you know, one cycle is going to be pi over 3, so then you got to cut it in half and enforce and go from there. So that's what that thing would look like. Let's do number 65 that says 5 plus sine x. So I need a little bit more room, so here's negative 1, here's 1. 1, 2, 3, 4. So really, I'm going to graph the sine curve. So again, here's 2 pi, here's pi. Now the coefficient in front of the x is 1, so I still get, and if I want to do 2 cycles of this again. So normally, all I'm going to do is I'm going to move this thing up 5 units. So it's just like having a new x-axis at 5. 1, 2, 3, 4. Whoops. Let me erase that because I put it at 6. Okay. 1, 2, 3, 4, 5. So here's my new x-axis. And so here's 4 and here's 6. So when you're doing this now, you have to start here and then 1/4 of the way, 3/4 of the way. This thing's going to look like that. So take that same sine curve and move up. On this side, again, same thing. So it's just like that's going to change your vertical. I don't think you get too complicated ones on your test. If you get something like 5/2 sine t minus pi, okay, just graph the 5/2 sine t. So how would I do that? Okay, so that just means 1, 2, 3, so this is at 5/2. 1, 2, 3, this would be at negative 5/2. So again, here's 2 pi, pi over 2. Alright, so I'm going to graph just this one right here, you guys. So it starts out at 0, 1/4 of the way, 1/2 of the way. Again, here's that. So it would be this. Now you got to move everything to the right pi. So let's graph this one over here the same way. So the dotted graph is this one. Now move every dot to the right pi. So I move that to the right pi, 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 and so now it just looks like this instead. So it's just going to be like a negative sign. Okay, hopefully that helps. Okay, if you were asked to do the tangent curve, tangent goes like this. Here's pi over 2. Here's negative pi over 2. And these things look like that. Here's pi, and this thing starts over again. So that's what that thing looks like. One cycle from 0 to pi. You won't have to worry about those calculator ones. All right, let's get into 4.7. And this is inverse sine. So anytime you have an inverse sine problem, this number in here has to be between -1 and 1. Where does sine equal 1/2 at? Where does sine equal √2/2 at? Where does sine equal 0 at? Where does sine equal -1 at? Now your answers always have to be Your answers for this have to be between negative pi over 2 and pi over 2. So where does sine equal 1/2? Pi over 6. If it was in degrees, it would be 30. If this was in degrees here, this would be between -90 and 90. Where does sine equal √2/2 at? Pi over 4. Where does sine equal 0 at? Now, where does sine equal -1 at? That's down here. But I can't write 3 pi over 2, so I got to go this way and write negative pi over 2. Arc sine is the same thing as inverse sine. So if it said this, my answer is negative pi over 4. Inverse cosine. Again, this has to be between -1 and 1. What goes in for x and what goes for y now is between 0 and pi. So if I do this, where does cosine equal -1 at? Well, that happens right here at pi. Where does cosine equal √3/2 at? Well, that happens right here at pi. Where does sine equal -1/2 at? Well, that happens right here at pi. Where does cosine equal -1/2 at? Well, that happens right here at pi. Where does sine equal -1/2 at? Well, that happens right here at pi. Where does cosine equal √3/2 at? Well, that happens right here at pi. Where does cosine equal -1/2 at? Well, that happens right here at pi. Where does sine equal -1/2 at? Well, that happens right here at pi. Where does cosine equal √3/2 at? Well, that happens right here at pi. Where does sine equal -1/2 at? Well, that happens right here at pi. Where does cosine equal √3/2 at? Well, that happens right here at pi. Where does sine equal -1/2 at? Well, that happens right here at pi. Where does cosine equal √3/2 at? Well, that happens right here at pi. Where does s This answers pi over 6. Arc cosine, and we're looking at, let's say, negative 1/2. Well, that's right up here at 2 pi over 3. So you really got to know your unit circle. Arctan, again, that has to be between negative pi over 2 and pi over 2. So where does tangent equal 1 at? Pi over 4. Arctan root 3, that happens at pi over 3. If I put a negative in there, then this one would be negative. So it's got to be in quadrant 4 negative or quadrant 1 positive. Negative pi over 2 to pi over 2 for arctan. Now if you ever get like an arcsecant, arcsecant 2, change it to arc cosine 1/2 because these are reciprocals of each other. And that'll make that a lot easier. Where does cosine equal 1/2 at? Pi over 3. This answer is also pi over 3. Now as you get to the ones that you have a combination, so here's like 87 on your review. It says find the cosine of arc tan 3/4. So draw a picture. So there's my triangle, there's theta. Isn't this the angle whose tangent is 3/4? So then you do the Pythagorean theorem and get that. You don't even need to find that angle. What's the cosine of that angle is what the question has. Answer 4/5 because cosine is adjacent over hypotenuse. What if this said find the secant of arctan? The secant would then be 5 over 4, the reciprocal of that one. Okay, so these combination problems. Let's do another combination one. Here's 89. Secant. Thank you, Chris. Inverse sine negative 1/4. Okay, guys, I'm drawing this in quadrant 4 because inverse sine has to be in this quadrant or this quadrant. So I draw my reference triangle, and here's my theta. So the sine is opposite over hypotenuse. So this side is 16 subtract 1, that's root 15. So the secant now is going to equal 4 over root 15, which is 4 root 15 over 15. And because I'm in quadrant 4, secant is positive. If this said cosecant, then I'd get of inverse sine. Then I'd just get negative 4 for an answer. Okay? So anytime you have these combination problems, draw the picture. Again, if you have inverse tangent 3/5 and they want you to draw the picture of it, it would look like this. And then now if you have to find the angle, you go to the calculator and you do inverse tangent 3/5 and you make sure you're in degree mode. And you get about 31 degrees here. Shouldn't be a problem doing those. Okay, then the last lesson is on all these word problems. So like number 93 in the review, the height of a radio transmission tower. So you got the tower right here. It casts a shadow. So the sun's up here and it casts a shadow. And so this is your shadow down here. 70 meters for this is the height. And it has a length 30 meters of the shadow right there. Angle of elevation is to find theta. So from this angle, tangent theta equals 70 over 30. Inverse tangent, 70 divided by 30. In degrees, this angle is going to be 66.8 degrees. So again, whenever you want to find the angle, go to the calculator and do inverse. I don't know, I don't think I put a bearings problem on your test, but we'll maybe practice that together in class. All right, study this, do some of these problems, and we